In this review session, we are going to work on some questions related to rates of change. Question number 1. Let f of x equals square root of 5x plus 2. Determine the average rate of change of f of x when x is between 1 and 5. Average rate of change of f of x when x is between 1 and 5 is f of 5 minus f of 1 divided by 5 minus 1. F of 5 is square root of 27, 3 cube root of 3. F of 1 is square root of 7, and 5 minus 1 is 4. Therefore, the average rate of change of f of x when x is between 1 and 5 is 3 square root of 3 minus square root of 7 divided by 4. Question 2. If f of x equals 3x2 plus x plus 1 divided by 5x minus 1, then x is between 0 and 2, what does f of 2 minus 0 divided by 2 represent? F of 2 minus f of 0 divided by 2 minus 0 is the same as f of 2 minus f of 0 divided by 2 minus 0, which is the slope of the line joining the endpoints of the interval 0 over 2. This represents the average rate of change of f of x, the given function, when x is between 0 and 2. Question number 3. Determine the equation of the tangent line to the graph of f of x equals x2 plus 2x at x equals 1. We know the slope of the tangent line is the same as instantaneous rate of change of f of x at x equals 1, which is limit of f of x minus f of 1 over x minus 1 as x approaches 1. It's the same as limit of x2 plus 2x minus 3, f of 1 is 3, over x minus 1 as x approaches 1. Can be reduced as, the function can be reduced as x plus 3 if we factor the numerator and cross out x minus 1. Therefore, the slope of the tangent line is limit of x plus 3 as x approaches 1, which is 4. The slope of the tangent line is 4. The point is 1 and 3. Therefore, y minus 3 equals 4 times x minus 1 is the equation of the tangent line. This can be written as 4x, y equals 4x minus 1. Question number 4. Show that limit of f of a plus h minus f of a over h as h approaches 0, and limit of f of x minus f of a over x minus a as x approaches a are the same. To prove this, We start from the left side. Limit of f of a plus h minus f of a over h as h approaches 0 is the same as limit of, we assume a plus h is x. Then h would be a x minus a. And as h approaches 0, x approaches a. When h is getting close to 0, a plus h is getting close to a. Therefore, this limit can be written as limit of, instead of a plus h, I put x. F of a is the same as f of a, and h is x minus a. When h approaches 0, x approaches a. Notice that both quantities on the left and right side of this equation are the slope of the tangent line at x equals a. Thank you.